Hi friends, welcome to CAT channel or Civil Architecture Tutorial channel. Today we discuss regarding lapping length and development length. So we know the difference between lapping length and development length, or I will explain the major differences of lapping length and development length. First, let's start with the development length. So development length is the length which the steel have to go so that it can transfer the stress or forces to a certain concrete or other member, that the steel will transfer that stress coming on it to the second member or the other member, that is it will be concrete. So that is the length that have to be acquired to transfer this force is called development length, or development length is also called anchorage length. So something to anchor a particular thing to some other thing. Okay, there also force is transferring. So anchorage length or development length we can say it. So that is development length. For example, you can see this is a beam and this is a column. Okay, so if this is the structural member or the steel member of the beam, you can see up from here or up to this level, this will the steel will come, and after that it will go like this and then go like this. It will like an L shape, so that it is anchored to this particular column member. Okay, so this much length from this area where the beam ends and from where the column stands, from this to this area, this length is called development length. And same like when we go for the lapping length, it is lapping one steel on the other steel. Like you can see here, if this is a beam, this is steel bar and this is steel bar. As you know, the steel bar have a limitation, that is the length will be limited. That is 12 meter is the usual length of a steel bar that we are getting from the shop. So after the 12 meter, what we have to do, we have to lap it with another steel bar, maybe of the same dia. Okay, maybe some different dia also it can happen. So the length up to which the lap should come depends upon the force that have to the grade of the steel, depends upon so many factors that I will discuss. But it's that lap length is a particular length which we cannot lap it just like that. If you don't lap it in the required level, the required force will not transmit from one steel bar to another steel bar. So that particular length, that is here, this from here to here, that particular length is called lapping length or lapping zone. And this is if this column, you know, one steel coming from the top and where it ends, and the steel starts with a joggle here. If there is no joggle, then the force will not transfer, we know that. So this length from where one steel comes overlaps the other steel is called the lapping length. So this is the definition of lapping length and development length. Then second, like I said, it is called the transfer of forces from one member to another member, especially if it is for a development length. It is the steel is actually transferring the force from one member to another member. Steel is a member and the second member is column. Okay, or the beam. From the beam, it transfers the force from the beam to the column. That is, the steel transfers. This is one member and the second member is column. So it transfers from one member to another member, especially in development length. If it is lapping length, what is happening? The same member, the same steel bar is transferring the force to another steel bar. That's the difference between lapping length and development length. The same member is transferring force from one member to another member. What is called? It is called lapping length. If it transfers from one member to another member, it is called development length. And the third one is, so where where the necessity of development length will come. That is the third point. That means when we have to give a development length, it occurs when the steel comes to an end. Always when the steel comes to an end, that area we need to go for development length. For example, the same thing. Here the steel comes to an end here. So that should be a development length. But here it is not coming to an end. It have to continue. Only for that we have to go for lapping. So when there is a continuation, we have to go for lapping, and when the steel member comes to an end, we have to always go for the development length. And what all factors on which the development length depends. Also, what all factors on which the lapping length also depends. So there are three factors. One factor is the dia of the steel, that is depend upon the dia of the steel, and also the grade of the steel. Die of the steel, you know how much it could be 8 mm, 10 mm, 12 mm, you know that. So it depends upon the die of the steel. Second is the grade of the steel, like Fe 415, 500, Fe 500, Fe 550, you can see it on the steel bar. So that is the tensile strength of the steel. So that the development length depends upon the die of the steel, as well as the this strength of this grade of the steel. And the third factor is the development length also depends upon the grade of concrete. That is a most important thing. That is the grade of the concrete, like M15, M20, M30, M35. So that the development length depends. That means if the development length, if the grade of concrete is high, for say if it is M50, then the lap length will be less. Vice versa it comes. If the grade of concrete is less, then the development length should be high. For example, you can see if it is we are going for a M40 grade of concrete, then we have to give 46D. D is the die of the bar. Okay. If it is 40, we have to give 46D. If the grade of concrete is M50, then we have to go for 36D. That means as the grade of concrete increases, the strength of concrete will increase. So the development length will come less. There is not much necessity or that much strength we don't need for the steel to bind with the concrete, because the concrete itself is strengther than the previous low grade concrete. Understand? So that is it. Then if we don't get any development length from the structural designer, then we can go for a common formula by which we can get the development length of development length is 50D, 50 into diameter of the bar. That is a common thing. If we don't if it doesn't specify, the structural engineer doesn't specify the development length, then we can go for 50D. Same case, what will be the lapping length? According to the IS code 456/2000, it says that we can go for either the development length. For the lapping length, we can go for either the development length or 30D, whichever is higher. So if it is the dia is 30 into say 8, you will get something. And if it is the LD is say maybe 900. So if it is 30D is 800 mm, and if LD is 900 mm, then go for the higher one. So that means then we will go for the LD. That is, whichever is higher, we have to go for the higher lap length. So that is one more thing. If lapping occurs when one steel member, the dia of one steel member may be different from the dia of the second steel bar. Means when the lapping zone lap comes like this, if it is a column, then as the column goes up, the dia of the steel becomes less. So at that time, which D we have to take? We have to take, that is, if it is 50D, which D we have to take? Which dia of the bar we have to take? That is, always go for the smaller dia, which will be on the top of the bottom bar, like this. The top bar will be less dia, so go for the, is it 50 into D? 50 into the dia of the small bar. So I hope I have covered what is called lap length, and also the anchorage or development length in this video. Hope you understand. I will come with another video with another subject. So till then, goodbye. Please subscribe, share and like. Thank you very much.